Right. So here is the question, and the question is number 2. And so the question, 30% of all customers who enter a store will make a purchase. Suppose that customers make independent purchase decisions. So find the probability that exactly 5 customers will make a purchase. So when we read the question about the probability distributions, I think the first thing that we have to ask ourselves is to identify the distribution in question. Because if we don't identify the distribution in question, then it will be a little bit difficult for us to answer the question that we're supposed to answer. Now, mainly the identification is based on our ability to identify the key features that guide each probability distribution. Yeah. So as long as we have the binomial probability distribution, we say that this is the formula for the binomial probability distribution, if you do remember what we said last time. Right. This is the formula. And so we say that we need to identify which one is our n, of which n is the number of independent trials that are given, and then P is the probability of succeeding in each independent trial. Then X is actually successes in the given number of trials. So let's say, so what is the value of N in question number 2? What do you think our N is?
Is it not 30?
Okay, so 30%.
Yes.
Okay. So, all right, now, so percentage and probability is at the same in this respect, okay? So the probability measures a percentage at the same time. So these are synonyms in research. So they are synonyms. So we shall say our probability is 30% being 0.30. That's fixed. What is our N then? What is our number of trials?
6.
Yeah, so there are 6 trials because there were 6 customers in total. And the X is the number of successes. So for A, what is our X? What's the value of X? So what is the probability that exactly 5 customers will make a purchase? So X is the number of successes. Every person that makes a purchase is a success to us. So what is the number of successes that we have? That is the value of X. So what is the value of X in question number?
5.
Yeah, so 5 is our number of successes. Then we can now compute into the formula. I think now you have practiced on how to do the combinations, yeah? So our N is 6 combinations of 5. Our probability is 0.30 to the power X. Our X is 5 times 1 minus probability is equal to what? What is 1 minus the probability?
1 minus P.
The probability.
Is it not P?
Yes, like 1 minus 0.3. Our probability is 0.3. So what is 1 minus
0.7.
Okay, so that is 0.70 or 0.7, still the same thing. So that is what we're going to put here, 0.70 raised to the degree N is 6 minus X is 5, like that. Is that clear now? Hello?
Can you just
Right?
go back a bit?
Okay. So are you fine on how we identify the P, the N, and the X?
Yes.
Okay. So we just compute into our formula. What we are doing actually is to substitute into this formula of ours. The value of N is 6. We'll put 6 where there is
6,
N.
yes.
X is 5. The P is 0.30 raised to the degree 5 because X is 5 times 0.70 raised to the degree N is 6 minus X
Minus
5.
5. Oh, okay.
You're fine?
Oh, okay. Yes.
So we move on. So what is 6 combinations of 5?
6.
The 6 combination of 5.
Yes, 6.
What does the...
Oh, maybe
Because
I forgot shift.
Yeah, so no, you don't shift. Just say 6.
No,
Then
it's 6.
there is that button in Sierra. That's the one you press.
Yes.
So it writes something like this. And
Yeah, it's
5.
6.
It's
It's
giving
6.
you 6.
Yes.
Okay. Let's say that is 6. Then you know where to find factorial. Let's do this one. Let's do it in this way again and see if you find the same. What is 6
Oh,
factorial?
okay. 720.
720. Okay. Okay, it is n factorial divided by n minus x factorial times x factorial, isn't it? So 720. What is n minus x, which is 6 minus 5? That would be 1, right? In the bracket.
1,
1
yes.
factorial. What is 1 factorial? What is 1 factorial?
1.
1 times
Yes.
x factorial. Our x is 5. So do 5 factorial.
120.
120. All right. So now 720 divided by 120.
6.
Okay. Can't you were correct? So it's a 6. There is that time when you doubt your students and you just see. Okay. So 6 times what is 0.3 to the power 5? Sorry that your calculator gives numbers in standard notation.
2.43. Yes.
2.
Then there is that, yes.
Times
2.43.
10
Then times 10 to the power negative 03.
negative 0. This one is a different
Yes.
calculator, right?
Yes.
Yeah. This is how it should be. This is now. This one is now reporting in standard or citations. So what you do, so that you're not confused, let's rely this one. This one means that for the point to be here, part 2, where it is, it was coming from a negative 3 steps. Okay. 2.43. So the point moved the 3 steps from the negative. So it has to move to 1, 2, 3, and then the point will stand here. So you have 0, 0, and 0. So this gives us 0.3. Have you seen that?
0. Oh.
You get the point, right?
Oh, okay. So to the
Have you gotten
power, so
-3?
because of this -3, we have to move back 3 times.
Yes, it means that the point moved from the negatives. That is from the left to the right.
Yes.
3 steps.
Oh, okay.
You got the point?
Yes.
Yeah. So you can record the answer. So answer is 0.00243. Is that right?
Yes.
What about the other one? 0.7 to the power 6 minus 5 is 1. So it's 0.70. Right? Then you can command your calculator to multiply all these things together. 6 times is times, okay, the way how it is, just multiply.
Okay. 0.010206.
0.010206.
0206.
Okay. Assuming that is the so this is what is there. Any question? So that is the probability of finding exactly 5.
Hello? Hello?
Any question?
Hello? Hello?
Hello. Is there any
Hello?
question? Hello, I can
No.
hear you.
No.
Is
It's
there
like
any
you were
question?
speaking in slow mode.
Hello? Can you
Hello?
hear me?
Yeah, I couldn't hear you clear. It's like you were
Oh, yeah.
speaking in slow mode.
Okay. Okay, can you hear me now?
Yes.
Now, are you able to hear me?
Yes.
Okay. So, but have you gotten, do you have any question?
No.
Okay. We go to the next question. The next question says, find the probability of finding at least 3. Now, what did I say about the word at least? The word at least means what? So you want the probability that x is at least 3. At least means greater or equal to what? To 3. You're following, right?
Yes.
So we are looking for the values where, x is equal to 3, x is equal to 4, is equal to 5, is equal to 6, since there are 6 altogether. Isn't it? We are also including 3 because this is less or equal to, or is greater or equal to. So 3 is included.
Oh,
But
okay.
you and I know that the total probabilities from 0, 1, 2, from 0 up to 6, right?
Yes.
You're following, right? So when you
Yes.
compute all these separately and add together, the answer should be equal to what? To 1.
Oh.
Isn't it? We say the total probabilities is equal to 1. So what you do, you can, instead of calculating for, you can see that moving to the right is a long distance than going to the left in the blue line.
Yes.
Here you can just compute for 0, for 1, and for 2. So,
Okay.
so the easiest you could do is just to say total probability, which is 1, minus the probability of x being less than 3. You get the point? It will still give you the same answer, which means you say 1 minus the probability that x is equal to 0, x is equal to 1, and x is equal to what? To 2. Then when you find these for 0, for 1, and for 2, you add them together. Then their answer, you subtract it from 1. It will still give you the correct. Did you get it?
Hello?
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 Oh, okay.
Yeah,
I can hear you now.
Hello, are you able to hear? I am saying,
Yes.
So basically that's what you are expected of doing. Okay. So you can less what is less than 3 from the total probability. That will give you what is greater than 3. If you remove what is less than 3, automatically you will find what is greater than 3, isn't it? Right.
So how do we find the same answer?
Okay, so you have to compute them separately. You have to calculate for 0, for 1, and for 2 into the same form.
Okay.
So you start with for 0. You can start with for 0. You start the n is still 6. 6 combinations of 0. What you just change is your x in this case.
Oh, okay.
0.30 raised to the power 0, 0.70 raised to the power 6 minus 0, which is 6. Is it? Okay, x is 0. So you can do this one quickly.
Okay, so on 6 combination 0, the answer is 1.
Okay, 1 times the
0.30.
to the power 0 is what? It's 1 as well, is it? And the number raised to the power 0 is 1. We know that. Times the, what is 0.70 to the power 6?
0.70. 0.176.
0.176. 0.11. Okay. Even 4 decimal places, I think it's okay.
Okay.
So when you multiply everything, 1 times that, obviously the answer will just be this one for 0, right?
Yes. Yes.
So again, you repeat the process. Now you just change it where there is x. You keep this answer. Keep this one for 0. So repeat the process now. Where there is x, you put what?
Put
You put
1.
1.
1, yes.
1. And here you have 6 minus 1, which will be 5. Right?
Yes.
You can do it.
So on the first one, 6 combination 1, it's 6, giving me 6.
Okay, 6 times this one will be 0.30. Okay, any number raised to the power 0 is times
0.
What is 0.70 to the power 5?
Okay, I'm confused. Why are we raising it to the power 5?
Kai, it is n minus x. Our n is 6.
Oh, our
So
x
6
is 5.
minus, our x is 1. N is 6. 6 minus our x is 1 in this case. So 6 minus.
Then it's 5. Oh,
Mhm.
okay.
You're fine now?
Oh, okay. Yeah.
What do you find?
Yes, 5.
1, 6.
0.01680.807.
Okay. So when you multiply now everything together, what do you get? When you multiply 6 times 0.30 times 0.16807. What do we find?
0.30. 0.302.
0.30.
526.
Okay. Now you have to do it with 2. You get it? Huh? Do it now with 2. Where there is x now, you put 2. 6 minus 2 is 4. What do you get?
So
6
on the
combinations
first
of 2.
one, 6 combination of 2 is 15.
15
Yes.
times 0.30 to the power 6.
0.09.
0.09. Right. Times what is 0.7 to the power 4?
0.2401.
Right. So now you have to multiply them, 3 of them together. 15 times 0.09 times 0.2401. Multiply them together.
0.32. 0.3.
Sorry, come again.
0.3 to 24135.
24135.
0.324135.
Oh, okay, 1, 2.
135.
Okay. So that's it. So you just add these probabilities now. Okay, these you add them together. Then that's the answer you put on this part.
So we
Okay.
don't include 3.
No, because we are looking for, it says, the question says at least 3, which means 3 and above. We are looking for 3 and above. So in what we are
Okay.
subtracting, we less 3. 3
The
is not
less
part of
C, which is
it.
okay.
So you can just add these together, find one answer. Then your answer should be subtracted from 1. You can just add them together and then less them from 1.
0.1 plus Okay. So the answer, if I add, the answer is 0.744295.
Okay. Then when you subtract from
295.
1,
Zero point two five five seven zero five.
25570. Yeah.
Mm-hmm.
So basically, this is the answer for the probability of 3 and above customers making a purchase.
Mm-hmm.
Any question? Hello? Are you able to hear me now?
Yes, I can hear you.
Any question?
No, I think this one is straightforward.
Okay. It is well. Then let's have the other part of the question is saying, what is the probability of finding what? 2 or less. 2 or fewer customer, which means 2 or less. Now the word 2 or less is same as less or equal to 2, isn't it? Can I rephrase the language by that?
Yeah.
Yeah. So it is less or equal to 2. So for less or equal to 2, it means x is equal to what? 0, x is equal to 1, and x is equal to what? To 2. 2 is included now in what we are looking for. You've seen that because it's less or equal to 2. So this is the probability that we are looking for 0, for 1, and for 2. So you just compute them separately and then add them together. On that, we found the probability for 0, right? For 1, which is 0, it was this one. For 1, it was this one. And then
For 2.
for 2 was that. Isn't it? Then we just add them together.
Hello?
The examiners know that these things, they take a lot of time. So sometimes they how they ask the questions. You find that you have already found, when you solve one, the answers are related to some.
So if you make a mistake on A, everything else will be
Hello?
correct or be wrong.
Hello, are you able to hear me now?
Hello?
Hello?
I don't know what's happening. You still, I can still hear you speaking in slow mode.
Yes. Everything will be wrong. Yes, madam.
Hello?
The improvements? Hello, is there any improvement of any kind? Hello, is there any improvement? Hello?
Okay, I can hear you now.
Okay, so I was saying, so you just do for 0, for 1, and for 2. Right. So basically that's what you do. Is there any question? Do you have any question?
So on C, tell you we already found the answers.
Yes, we already found for 2 and less, 2 or less, which is the 2, 1, and 0. So you just add them together, and then that's the answer you provide.
That's the answer. Oh, all right. Okay.
Yes. Is there any question?
No.
Oh, you don't have a question.
Okay, what if they say the probability that 2 of you? I think I need to get used to the terms at least.
Language.
Yes, the language. Yes.
Yeah. So if they say 2 or more, which means they're looking for greater or equal. Yeah,
Okay.
it's same as at least, 2 or fewer or less is same as at most. The way the at most means less or equal. Is that right? At most, yeah. So you can say, how many times can I call you? You can call me at most 2 times. When I say at most 2 times, it means that's the maximum you can call me.
You can.
2 times.
Oh, okay.
Yes, so the word
Okay.
at
So at
most
most
means,
less or equal to.
yes, it's less or equal to. Then when I say, you can call me at least 2 times, that simply means you can call 2 times or more. That's
Oh, okay.
how we understand these words. That's the correct meaning of them.
Okay.
Yes. Okay. So yes. Okay. The size is speaking so fast and we are unable to hear what he says. How true is that statement? No, it is not true. Okay. Here is another one. Another rephrase. Question number 3. If the z is normally distributed with the mean 0 and the variance of 1, can you find the value of z such that the probabilities are these? So in short, with this question, they already went to that table. They got those probabilities already that correspond to the z values. So now you need to find those z values that correspond to these numbers. Did you get it? You need to get the z values that correspond. We are looking for z. Find the value of z. Remember last time we had the z's, then we are using the z's to find the probabilities. Now you have the probabilities. Then can you find the z's that correspond? Yeah, to the same. It can be very interesting language, yeah?
Yeah.
Okay. So let's start with the first one. So this one is z is less, right? The z is less than the critical z. Okay, so it's less than that, which simply means, let me just give you to visualize. By less than z, the critical z, like a small z is here. This is z1. You've seen, right? So on that table, they are asking, this is negative z1. They are asking for which area, which is less, right? This area, which is less. Are you following? They're looking for the area which is less than this. The area less than that. But you know that our area, our probability distribution, always that one we have gives us the areas that are greater, right? It gives us the areas that are always greater. So if we want the areas that are less, obviously it means that those areas that we find like they have to what? They have to be subtracted from 1, isn't it? I'll repeat that. That probability gives us what is greater already, right?
Yes.
Yes, that's the area that it gives us. So now they have said that this probability is for the area that is less, that is already less. So we can
on the left side.
Yes, it is on the left side. So
after resist.
yes.
No,
So how
before
can we?
the z1 and the positive
Yes.
z1. Okay.
Yes. So how can we find that area which is actually less than that?
Okay.
So to find the area that is less than that, it means that this critical area that we find here, this one, we have to subtract it from 1. Then we look for the answer that we find. Okay. The answer that we find is what we actually the answer that we find is actually the one that we that we check the probability that corresponds to it. So this is the area already given, and it is less. Okay, it is actually less, which means that when you find this area, when you find this area has to be subtracted from 1 so that it can give us the area that is on the alpha side. So you can say 1 minus this area, 0.6985. What area does it give us?
0.3015.
0.3015. This is the area that we are looking for, which corresponds to the area after the z-score, right? This area is after the z-score. So it can at least help us to find the critical value. Okay, the area that is after the z-score, when we subtract this area from 1, then it will give us this area, which is less. Did you get the language? I will repeat. Our z-score gives us the areas that are after the z-scores, right? But this area that we are given here, we are told that it is less than the z-score. Yeah.
Oh, okay.
So if we want to find the correct z-score, we need to subtract this area from 1 so that we can find that area that is after the z-score. So when you go to the table, we are looking for this area because this is the only area that you can find. We can't find this one on the z-score. We can't find this one because the z-score that we have, just the table that we have just gives us the areas that are after, which are these small values. So let's go and look for the area 0.3015. You get the point? We are looking for the area 0.303015. Okay. Okay, so it is the 3015. So 3015. Zero point 0.3015. 0.3015. Ah, are we going to find it? Yes, we will find it. 0.3015. Have you seen it? It's here. Wow, this is very beautiful. 0.3015. Have you seen it?
No.
It's here. Can't find it?
Oh, okay.
0.3015. So what you do now, the z-score has got 2 decimal places, isn't it? We used to first pick these 2 decimal places inside. So 0.5 plus the other 2 decimal places upward, which are
0.02.
Yes. So our z-score is what? 0.52.
0.52.
You're right.
Oh, okay. This is interesting.
So that's the value of the z-score.
Okay.
Yeah.
Okay, so
That's the
it's
value
taking us back to where we started from.
Yes. So if we
Last
want
time.
now,
Okay.
if we want now, we can resolve the question given the z-score to just prove the answer that it gives us. We have this z-score. Now we are looking for what is less than this z-score, isn't it? Less than this z-score. So we have to go on the value where we have 0.5, isn't it? And
yes,
0.02. You're finding this,
yes.
area that we have found. It is after the z-score. Our z-score is 0.52. Are you following?
Yes.
So this area 0.3015 is after the z-score. But as we want which one? Less than the z-score. We want all these points. So you subtract this from 1. You say 1 minus 0.3015 equals to, when you punch your command, when you command your calculator, what do you get?
1 minus 0.3015. Oh, okay. It's taking us back to 0.6985.
Yes. as simple as the ABC. Right.
Oh, okay.
You're fine now? Don't
Yes.
worry, you will be fine in this hand. You will be okay. You'll be very much okay. I will take good care of you. Let's go to the next question. I'm hoping that you are following and you are following through the lecture. Now look at this
Yes.
one, the way how it is behaving. Have you seen that? See, this is Z is where is greater than the critical value. So this one will be even be easier. You've seen it, huh? Because the Z value that we are looking for is already after the critical value. Have you seen? So like a small z, the Z1 is here, Z1. So this is Z, is the after. They've said it's greater. So you're looking
Yes.
for the area which is already greater than this one, which will be very easy. So since we are already looking for what is greater, what is the need of suffering? We just go to the table and look for this area. Because we will find this area. Since the table already gives us what is greater, let's go and look for this area. You get the point?
Yes.
So let's go to the area. And we are looking for 0.0526.
26, yes.
0526. 0526. 0526. 0526. 0526. Is it? 0.0526, right? Hello?
0526. 0.0526.
Where is it? Are you seeing where the 05s are? 0.0526 is. Have you seen it? Have you seen it?
Oh, yeah.
Hello?
Yes.
This area now is after some z. Some z value is here. So the area is here. This is 0.0526. You're following, right?
Yes. Yes.
But we want this z. How can we find this z that corresponds? You just pick two decimal places here. It's 1.6, right? That's where it lies, isn't it? And which one?
0.02.
0.02. So it is 1.62. And you provide the answer. That's the z score.
Okay.
If you want now, you can go direct. Z score greater than this. It will just come here, giving you the answer. You are okay. Hello?
Yes, I can hear you.
Okay. Do you have any question?
No.
Okay. It is a good thing to learn that she doesn't have questions. So, sir, you can proceed. Okay. Now, we have this one. Have you seen this one? The next one now, Z is equal. You're following that one? Z is equal to this one. How is it when you visualize the Z value? So our critical Z, Z1, and the negative Z1 is here, 0. So we want Z is equal to which value? This is like this. This is what you.
Yes.
Isn't it? Yeah. So how can we find now the area? Because this value that we have found, if Z is equal to that, it means that it's between 0 and the Z score. But the area always gives us what is Z after this. How can we find what is after this? This is not less. This is just in between.
Mm-hmm.
Okay.
Mm-hmm.
So when you look at this number, so you can subtract this entire number from 1 so that it can give us a critical value that is on the other side. Because this number here,
Mm-hmm.
if you check it, it is actually almost greater than 1. So that the table, this one, yeah. So it's greater than 1, this one. It's almost closer to 1. So you can say 1 minus this number, it will give us the critical value, the critical Z. What number is it?
1 minus 0.9 0.025.
Wow. So that is the area which falls this side, 0.025. So we're going to look for the area which corresponds to what? To 0.025. Simple. So let's find that area which corresponds to 0.025. And for the area that corresponds to 0.025, are you able to locate it? This one you should find it. In which line? Say, yeah, 0.025.
Zero to 0.025.
Yes. Where can we find it? Which line, which row?
6, 0.6.
0.6, this row?
No, the top one is 0.6,
0.6
1.9. Yes,
and
yes, and
1.
1.9. Yes.
Good girl. So you have 1.9, 0.06. So that you have 1.96. This is the Z score. You have found it?
Yes.
So that's what is there. Do you have any question? Is there any question now?
No.
So this is your Z. No question.
Yeah, no question.
Okay. If she doesn't have questions, we can go back to the other question. So this is what is there. Life is made very easy. The last one, Z is equal to what? 0.05. Z is equal. Now, look, see how our table is. From 0 to this is Z1. So they're saying that this area is what? 0.005.
0.005.
So our Z score gives us on the right. So we can just subtract this area from 0.5, isn't it? We know that on the right side we have 0.5. This side we have 0.5. Also this side we have 0.5. That's what they say. So in total you have 1. So 0.5 minus 0.005 is what? That is the area that falls on the right now. Let's find the area that is on the right. What is the area that falls on the right?
0.495.
0.449.
495. 95.
So you have to actually now look for this area on the table.
Oh,
Yes.
okay, let me just take you back a little bit. On C, I don't
On
think we
C.
subtracted 0. Yes. Is it not the same
Yes.
question?
Oh yeah, I see. So the C question was a little bit different. We should have subtracted this value from 0.5, but you see how it is. It will give us a negative value because this number is already closer to 1, which simply means that you've seen, like it's like the table that they used on this one. It's a full table. It's that table which gives you these probabilities like this. It is shaded on all this side. There is the other table that is shaded on this side. Then it's not just shaded on this, on the Casmo. Then this one is the P that it gives. So there is another table. I think that's the table they use for this one. So that's how different it is. You can't subtract this number from 0.5. It's not possible. It will give you a negative.
Oh, okay.
Yes.
Oh, okay.
Yeah. So, but you
So
know that
how
the
do you
probability.
differentiate the two?
Okay. How are the two different? Always because we are looking for the number that is less than it is less than 1. So when you look at this number that falls, the numbers that fall on the other each side of the equation, they should all be less than 0.5. This side.
Okay.
So that when you total them together, they should just equal to 0.5. But if you see that this number already exceeds 0.5, that simply means it came from a full table. You understand?
Okay.
And just because of the equal sign. Okay? So let's go to the table and look for 0.495.
Yeah.
Yes, we are looking for 0.495. 0.495. 0.49. 0.495. Okay. 0.495. Can we find that? 0.49. 495. Is it possible to find that? Yes, it is possible. 0.49. Have you seen now? So this one was a little bit interesting. You're seeing the line that we have. So there is just 0.496 and 0.492. You've seen that, right?
Yes.
So if you want 0.495, unless we average these two, yeah. So just add these together. 0.4920 plus 0.4880. When you add them, then you divide the answer by 2.
Mm, 0.49.
0.49.
49.
449, of which when you round it off to 3 decimal places, it will be 0.495. You've seen that, right? So, which simply means that it is actually the first decimal place will be like the Z will be 0.0. Then the other 2 decimal places is the average of the 2 that you have averaged. So you do 0.02 plus 0.03. You add them, then divide by 2. You average those which are on top as well.
Oh, 0.2. 0.05.
Now divide that by 2.
0.025.
Okay, 0.025. Add them together, it will have 0.025 as your z. So maybe your z can just be rounded off, I think, to 2 decimal places, since it is always so it will be, your z will be equal to what? Will be 0.03. I think round it off to 2 decimal places. Is that right? Any question now?
The last one.